Guten Tag, class. This is Mike Sturkle, and Guten Morgen for those who are viewing this in the morning. I am part of the group Live for Your Data. Fellow groupmate is Joey Netterville, who gave the in-class portion. And let's begin with this online thrilling presentation. So we are doing the reducing the networking skill gap topic. And to start off, we're going to break the ice with a comic on what people think network engineers do, and a little bit cartoon about wireless. Now, our research revolved on three questions. Why is there a network engineering skill gap? So what is causing us to need highly skilled network engineers, but there aren't any to be found, or very few? How can we reduce the skill gap? What does training need to be different? Do we need to implement new training methods? How can we reduce the skill gap? And does new technology like software-defined networking or SDN make the skill gap bigger, smaller, obsolete? Just from the, we went into the literature and the research to find out. So the reason the basis for the topic really is kind of this example that Joy brought up of where they lost a 15-year veteran, and they put a requisition to fill a spot and received 300 applicants for this. And of the 300 applicants, not even 10% were what could be considered even semi-qualified, and 1%, so 3 applicants were interviewed. So 1% total applicants had enough of the skills to at least be interviewed, and even the person finally selected really was underskilled. And it kind of just shows that this person is just going to have to sink or swim in the position because there's no time to really train on the job for this position, because they were actually looking for a person who had the skills already, but they couldn't find them. So for this semester in this project, we developed really 3 main outputs. One was a literature review. The other was simulation-based curriculum using Cisco IRL. Last was a analysis paper of really the skill gap problem. And here are the research methods we use. We decided to use a qualitative research methods, which our population of interest was network engineers, academic businesses. The data we collected from text-based sources, personal experiences. We reviewed the literature. We looked at simulators, off-the-shelf and COT software, and examined future technologies like I talked about, SDN. Now, these are 3 kind of topics I pulled from the literature and some sources that fell into those topics. One was training and how those being trained at academia really weren't in line with what business we're looking for, and even to the point where USF had a pilot course where they actually partnered with industry to make a course that allows students to learn skills that were what a business considered that they needed out of graduating students. In the gamification virtualization kind of topic, it looked at these kind of papers looked at how networking concepts are being taught with games, interactive virtual environments, and how that doing this, actually making these games, was a valid way to teach these networking concepts from basic to advanced. And on the actual use of simulation for training, these sources kind of showed that it is an effective avenue to train. It allows students to repeat levels at their own pace, which increases their motivation for learning, increases their ability to want to continue to learn the topic and move on. And it kind of transfers the training from teacher-centric, where a teacher presents material to students and really allows students to get in and master the concepts by being able to work with them pretty easily after being at least addressed to the topic. In the paper we looked at the issues relating to the skill gap, kind of what are some of the causes from this mismatch between academia and industry, to how companies are employing network engineers. And then we kind of looked at what kind of training would be used to help that. Mentoring was one avenue brought up. Other was teaching all entry-level engineers the same material to give everyone the same baseline. Others was teaching specific topics, which is kind of what the certification like Cisco and Juniper do. Other topics were, how do you get more people into the field? Are expos a good way? Do you need to give more demonstrations? And then we looked a little bit at how future technology and how you would learn that technology, how it affects the skill gap. And it kind of seems that if you are going to this new technology such as SDN, the skill set needed there is not the skill set of the current networking paradigm, meaning that you may not need to even learn old concepts and just learn new ones. So there wouldn't even be a skill gap for SDN as everyone is being taught these new principles. But does this mean that you're widening the skill gap for those who need the old stuff? And how do you bring along those who are currently in the old way to the new way through training, which also can be done through mentoring, simulation-based training to teach the new concepts, just as if you were a new person in the field. Now, for the curriculum that we created, we used the Cisco VRL, which stands for Virtual Internet Routing Lab. It has some heavy requirements for processing, and unfortunately right now it is not portable, but we felt this was the best application to use to create the training that we wanted. Now I'm going to quickly go over the Cisco VRL software. This is just a brief overview of the GUI. Here's the simulation workspace, some of the tools you can use in terms of dropping different equipment in, project lists. Here's interface, the terminal where you input commands, layout, virtual devices, VLAN. So here's the first lab we created, which the objective is to configure connectivity from C1 to C2 using MPLS or Friday Core. So in this scenario, we have like 4 different scenarios you could be doing, or concepts that we want to be taught. And lab 2 gets a little more advanced, where one of the scenarios you want to reconfigure topology. So CE2 can talk to CE3. As you can see, how you have to, or at least how topology is, you have to work with. And 4 is kind of the capstone of the 3 lessons. And you have to troubleshoot this to make sure that you can properly communicate between the devices. Now back to the presentation. Now, kind of overview what we talked about at the lab really focuses on scaffolding skills, where you train more advanced concepts after you learn the simpler ones and build harder levels. And really the reason for doing it that way, and also just using the simulated environment, is that you can practice repeatedly concepts over and over until you get them. You can make mistakes over and over again. You can make mistakes on purpose to see how it breaks the network, which aids in learning. And all this doesn't affect your operational network. You don't have to worry about breaking it so people can't get their email, can't get on YouTube, can't communicate with each other, can't transfer files that are needed. And also you can use these kind of simulated environments to test new implementations of a network, to find the errors that may have been made in the design that no one knew or wouldn't have known until it actually was put into practice, which saves money, saves time during the actual implementation. So all these are definitely benefits to a simulated environment such as the VIRL. So some of the key results from really our analysis is that training isn't really keeping up with the changing technology. Old concepts are still being taught in the university just because curriculum can't change that fast. And even the certifications are lagging behind because technology is changing. So it's just curriculum in general is not keeping pace with changing technology, which leads to new entries into the field being taught concepts that are already outdated. Another big item was that simulation is a viable means to train. It helps with motivation. It allows a safe space for working out bugs, out issues you may have, out just concepts you may not understand. It brings concepts maybe that are abstract or easier to understand. And the other thing was that new technology such as SDN looks like it's actually eliminating the skill gap in one sense, because you just need to learn this new technology and how to implement it, but not helping the old skill gap because it has nothing to do with it. It's new in different skill sets. So now you got to worry about bringing these older generation who knows the old skills into the concepts of SDN. Now, this kind of goes into why simulation makes for a good learning, is that it's really getting down to the motivation of the students. The simulation helps motivate students, and it helps to improve scores. This was seen over multiple papers written on courses where simulation was used, where gamification was used. It shows that it made the lessons more fun, made the students want to keep doing it, and allowed you to grasp concepts that may have been very difficult or abstract due to maybe not being tangible to touch normally. And then we also look at the fact that mentoring is a viable way to improve learning, and something that should be implemented more for teaching, networking at businesses, and even academia. So next couple slides are kind of just going over the scope of what we did in terms of there's a lot of material to go over. It's just a huge topic in general that we try to keep in check as best as possible with working with two people who had different concepts of the topic and maybe areas they wanted to focus on, and just making sure it flowed and actually answered the questions that we wanted to, and that we've really barely touched the surface on it because it's such a topic that you go into such more detail than we did. We already had 30 plus pages of material, and that was with editing out areas that may have been slightly outside the scope that we were looking for. But with more time, we could easily expand our curriculum because we only have 2 or 3 examples, and we could easily expand that to more, and then actually test to make sure that what we have created properly conveys the concepts with a pilot study to see how well we're transferring knowledge. Do we need to adjust it based on, am I teaching to a novice person or teaching an expert? Do they learn differently? Do they need to be presented differently, the material, not just what the concepts are, but how the concepts are being presented? And then if we had 2 more semesters, we would complete everything that we did in semester 1, but also then go back to our analysis paper and incorporate what we learned from not only the pilot study, but also interview fellow network engineers to get their perspective and insight into the problem. Maybe that then backs up what we've researched, adds new areas that need to be focused on, and then with all that, we would refine the paper to really make sure that the scope is clear, that we've covered the topics in enough depth, and make sure the answers were clearly identified and given the right amount of research behind. Does anyone have any questions? I don't hear any, but I'm going to give one for you. Why aren't them reports getting so much larger in the inside? So this is the TARDIS, those who don't know. It's a Doctor Who joke. I'm sure those who like Doctor Who got a chuckle. I know Dr. Cutter did. Well, Thank you very much for listening, and goodbye.